Hello, YouTubers and fellow hams, RVers. Well, it's mid-November, and last night when I was out taking my walk around the RV park before bed, I look up at the sky, which I usually do. I like to look at the stars. And I saw a meteor. And before I was done with my walk, I saw 2 more. And I thought, hey, it's mid-November. That's right. Which one is it? Perseids? I think it's the Perseids, not the Leonids. Leonids are July, right? It's one of those 2. I might have it backwards. But I think it's the Perseids. Meteor shower coming up this week, I think. So, yeah, you're seeing this after. Well, anyway, it was November. It is November for me. And meteor showers mean meteor scatter and VHF activity, interesting activity on perhaps 6 meters. Well, I don't have a 6-meter antenna up. I guess I'm going to make a dipole today. I'm going to make a 6-meter dipole. Nothing fancy, just a straight-up coax-connected dipole. But I need a center insulator for it. I had one before I left Fort Wayne. I'm sure I packed it somewhere, but I've dug around my boxes and I can't find it. Well, you know, I guess it's time to get the 3D printer out. I wanted to find out how well it traveled, because it's been a long journey down here. It's packed away. I'll show you in a moment. We'll get it out, and I'm going to print a new dipole center, and then I'm going to put together a 6-meter dipole. Now, the measurements for a 6-meter dipole are just over 4.5 inches per leg, right? A total of a little over 9 feet. Did I say inches? A little over 4.5 feet per leg. 4.67 feet, I think, is the common measurement. I'm going to have a center insulator with a BNC connector, and I'm going to have the wire coming in and tied to that center insulator on each side. And then at the end of the wire, I'm going to have a little loop that I connect the string to put it up in the tree. So I figure I need to add about 2 inches to each leg of wire that I cut to accommodate that loop at the end and the tie at the insulator. And I think that's going to get me pretty close. And then we'll put it all together. We'll stick it up in a tree. We'll come back in here and use the mini VNA to check it, scan it, and see what the SWR is across it. And as long as I'm pretty close, I think I'm going to be all right, because the 7300 that's sitting behind here, it has a built-in antenna tuner that works on 6 meters also. But we'll sweep it with the VNA and see how it goes. But first things first, we need that center insulator. So let's get the 3D printer out. So this is where the printer has traveled for the past month and a half, safely bundled down here under its little table. And as you can see, I have foam packed on either side of it. There's a garbage bag that's over the mechanism to keep the dust and stuff off. And down here along the bottom, there's a barrier that kept it from sliding out. And some foam blocks are packed in underneath there, holding the bed and the carriage, which is pressed down into the foam. So it should be just fine. So we're going to get the foam out, put it up here on top, and see what it looks like. Okay, so here's the good news. Howdy. It's kind of cramped in here. I kind of got to scooch in to get in frame. I checked the bed leveling because I was, it's been vibrating and bouncing around the whole way here. It was only very, very slightly off. I only had to tweak each corner just the teeniest bit. And it's the standard method. A single sheet of paper, you slide it in there until you feel just a little bit of resistance on each corner, and you make your adjustments so you just a slight bit of resistance in your level. So it was only just a teeny tiny bit off. That's good. I thought it would be way off. So I went ahead and loaded up some filament. I have the model for my antenna insulator. Oh, does it go that way? Yeah. So I've got filament loaded. I got the SD card in. I'm going to go to the print menu and select the G code that I just rendered for that and hit print. And we should be off and running. And I should have a center insulator here in about an hour and a half. Okay, here is our dipole center, all printed and ready to go together. I have a BNC connector with a ground lug on it, so we're going to put that in here. Now I'm putting it in here, and I wish you could see that. I'd have to set up my close-up camera, but the pin on the end of the BNC connector has sort of has a shape like this, right? So it's like a cup shape, so a wire can set in that depression, and I'm putting that up so I can easily get to it. If I put it down, it would be harder to solder. So if your BNC pin has that cup shape to the tip, make sure the cup is up, not down, right? So you can just lay the wire into it when you solder. It makes a big difference. I've got my BNC installed, and this design has just enough room to where you can put a BNC connector in there and engage it. It's a great little center insulator. PLA is strong enough for most simple dipoles. I mean, if you were putting an 80 meter dipole up, as long as you had a center support, this should be strong enough. You wouldn't want to put all that tension on there if you had the coax suspended from it without a center support and just the wires. I don't know how strong the plastic would be. But the nice thing about the design, and this design is up on Thingiverse, it's an open design. So you could easily take this and just make it thicker. So, yeah. So I'm going to fire up the soldering iron, grab my wire strippers. And yep, I now have proper wire strippers. How about that? And we'll just strip enough of the end here to connect around. Just go around that once, like that. And there's a good strong knot. And then we'll bring the wire down here and we'll connect it. It's going to fit right in there. And then the other wire for the other leg. Alrighty, soldering is done. There is our dipole center, all ready to go up in the air. Temporarily. If I was going to leave this out and out in the elements, I would probably want to dope up this end, this exposed end with the wiring and the BNC, backside of the BNC connector with silicone rubber, you know, and I probably will ultimately. It's not going to rain for a couple of days, and I'm just going to put it up for a day or two. So it's up there, not too high above the roof of the RV. Coax comes back and connects to my box right there. Few false starts throwing it up there, but it's up. So yeah, we've got about, I don't know, 11, 12 feet of height. It's enough to play with. Let's go in and check the tuning on the antenna. Well, I'm not exactly sure what's going on with the Mini VNA. I've calibrated it, and I've checked, and it shows the low SWR on this antenna being all the way up at 53 megahertz, which doesn't make sense. And it shows around 2 to 1 down at the bottom of the band. Now, I've swept it with both the Yaesu and the ICOM, and as you can see in the screenshot here from the ICOM, down at the bottom end of the band, the SWR is just under 1.5 to 1, which is about what I'd expect for this antenna. And by the time I get to the top end of the band, I didn't capture it, but it was still below 2 to 1. And at the bottom end of the band, it was just a little bit higher. It was about 1.5 to 1. So, yeah, the radio is indicating what I would expect to see from an SWR. The Mini VNA is wacky, so I'll have to look at that some more and see if it's a software issue or what. And yes, I did calibrate the Mini VNA. I calibrated it twice, so with the calibration plugs provided. I'm just trying to cover all the bases because almost certainly somebody's going to be making comments about something I've already covered. But anyway, yeah, so the antenna gives me what I pretty much expect for that length. And it's a pretty standard dipole, 4.67 feet each leg for a 6 meter dipole. And we're seeing less than 1.5 to 1 SWR directly with the antenna. I can tune the tune button on the ICOM and bring that down to 1 to 1, but it doesn't really matter at this point. I mean, less than 1.5 to 1 is fine to operate across the whole band. Now I just need an opening on 6 meters. CQ, CQ, CQ. Hello, CQ, CQ6. This is Kilowatt Bravo 9er Radio Lima Whiskey. Kilowatt Bravo 9 Radio Lima Whiskey Portable 5 calling CQ and standing by. And that's how it goes with 6 meters. You have to wait for the openings. But I've got the antenna up, so I'm ready to go when the band finally does open. By the way, little ICOM 7300 tip. Some of you might not have known about. The meter here below the frequency, if you touch it, it changes function. Now it's showing ALC, now it's showing compressor level, now it's showing, oops, didn't want to do that. Now it's showing the current on the finals. No, that's current. The other one was power. No, that's power. I don't know what the V was. Voltage? And SWR, which is what I like to have up. But you can tap the meter and change the function right there. And what it will show you. So it's S meter when you're in receive mode. Now it's SWR when I'm in transmit. That's handy. A lot of stuff on the screen is interactive. So anyway, that's building a 6 meter dipole. Now all I need is a band opening. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.